Hello, in this session, we are going to open what is called as a BMP file. So let me just note down. So it's a BMP file. What is a BMP file? So BMP files are files which store images, some the pictures in your computer, etc. Some of them might be stored in what is called as a BMP file format. Okay, so it's a file format. It's a format for storing pictures. Right, so BMP is probably the oldest of the file format. It's the simplest file format. So there are multiple other file formats like um, uh, GIF, GIF, and JPEG. You might have seen in JPG, JPEG, etc. So these are slightly different file formats. BMP picture file format is in what is called as uncompressed file format. So it is uncompressed. What do I mean by uncompressed file format? Okay, so you might have seen zip files, right? ZIP. What do zip files do? If you have a file, zip, you can zip it, right? So that basically it compresses the file. So the file might be of, let's say, 10 MB. The zip will convert it into 2 MB or 3 MB file, right? So it basically compresses the original file into a smaller file. So the main idea is basically, identifying patterns and using those. If there are repetition of patterns, then you use that fact to compress the file. So zip and what is called as GIF, GIF, they all use a compression technique called as Huffman coding. That's something you will see learn later in an algorithms course, or you can just Google and look for Huffman coding also. Maybe there might be YouTube videos also to explain Huffman coding. So zip and GIF, zip, GIF are use Huffman coding. So they compress the file, but their compression is what is called as non-lossy compression. So there is no loss of information when you compress. You compress your text file, and then when you decompress, it's exactly the same file you had in the beginning. So that is zip and GIF does that. On the other hand, JPEG, JPEG, it's what is called as a lossy compression, and it's usually used for pictures. That's in the JPEG compression. Some part of the image information is lost when you compress it, but it's not a problem, because for humans can't perceive that change when JPEG compresses a file. So from the perspective of the human visual perception, there's no change in the file, except that in the original file a blue might be changed, the blue color might be changed to a slightly different color without us humans perceiving that change. So the JPEG uses many functionalities, which it uses the fact that certain colors humans can't perceive. I mean, the certain color humans can't distinguish, and therefore you don't need to have two different colors, etc. So those things are used in forming a compression technique called JPEG. So it's a highly advanced compression, and it's usually the one which compresses the file the most. So we are not going to, right now we are not going to look at any of the compression techniques. What we are going to use is we are going to take a BMP file, and we're going to open it in our C program. So which it's basically a picture file, right? So we're going to open that picture in JPEG, in our C program, and finally what we can do is the following. We can just see that picture in, let's say, text mode. Okay, so if you don't understand what I'm talking about, text mode picture, forget it, we will see that. So that's what our plan is. Open a BMP file, and you also need to understand how pictures are stored, right? How are pictures stored? So we'll come to that a little later. when we actually look at the picture. First thing is that how do you open a BMP file, and then what do we do with it? Okay, so let's start the procedure. How do I open? So obviously we need some files, some header files. Let me just include the standard header files we will be requiring. And I'm going to have our main function, which basically, let's say, open BMP file. Okay, so it's just going to call a function which opens a BMP file. So I'm going to just have that, and right now I'm going to open. I'm going to write file fp equal to f open, and let me say this is my file, and I'm going to open this. Okay. Now I'm going to open for reading purpose, right? Because I want to read from that file. And one catch, I could have put R here to read that file. Now, except that if I put R, I can put R to read that file only if I want to read what is called as a text file. Okay. Text file is something which you can open here in your any text reader and see. But you can't open your BMP files or your non-text files in a text reader. So if you don't want to, so if the file is not a text file, you have to put what is called as RB to mean that it's a binary file. It's a non-text file. So I use that to open that file, and let me just write f close fp here itself, and then I'm going to write everything in between. So I opened the file and I've closed the file. Right now I'm going to read the BMP file. How is this BMP file? So what are the contents of this file, right? So what is the first character of the file, etc. So we need to understand that. How do we even know it's a BMP file? Okay, we know that it's a BMP file from the file name, but maybe someone can just change that file name, but still that does not mean the information contained inside the file is lost, right? So it's encoded inside the file that it's a BMP file. Moreover, it encodes a lot of other information like what is the length and width of the file, etc. This is what we're going to do. So one catch here, what I'm going to say. Okay, so there are multiple versions of BMP file formats. That's simply for the simple reason that BMP has been around for a long time, 20-30 years. The BMP file format has been around, and like any other thing, it has also undergone changes. So people have come up with new versions of the BMP file format. Okay, so there's an old version, there are new versions, there are newer versions, etc. And some of the new versions have compression inside it. So there are some BMP file formats which has compression. We are not interested in it. We are interested in BMP files which does not have compression. Okay, because we are not going to do compression and decompression here. So there are some file formats which does not do compression, and some BMP files which do not have compression. Those are the files we are going to open. So as we said, there are multiple versions of BMP files. There are and a lot of other information which we need to know. Is it using compression? What compression are we using? And what is the length of the image? What is the width of the image, etc., etc. And for these reasons, all this information, we need to know all this information before we even start reading the information contained in the image, right? So to do that, all these information are basically collected in the beginning of the file, which is called as the Bmp file header. It's called as a file header. So there is a file header for a Bmp file, and we need to first read the file header, and file header contains certain information which we can use it for the reading the image parts. So let's go to the wiki. So this is the Wikipedia page for the Bmp file format. Okay. Now, so as you could see, so So the header information contains a lot of things, but what we are interested in is the following. So this is what is the first header. So the first header is the initial 14 bytes of the BMP file will contain this information. For example, the first two characters are going to be B and M. Okay, first two characters of the BMP is going to be, so these 2 bytes are going to be the characters B and M. Sometimes it uses BA on these things. So these are different versions, but we are going to stick with the BM version. That's what we're going to do. Next thing, the next 2 bytes is okay. The next 4 bytes will basically talk about what is the size of this BMP file. The next 2 bytes and the next 2 bytes, we don't have to care. It's set to 0. It's we don't need to worry about it. The 4 bytes which comes later is basically tells you where is the image information going to start in this file. Okay. Until then, you can have a lot of other things inside the file. There are other kinds of header information, etc., can be stored in after this 14 bytes. But after all those things, the image data is there. So where is it? After how many bytes is this image data? So that is the fine. So that's the next 4 bytes. As you could see here, this is somewhat like this is how the BMP file format looks like. So initially this is the first 14 byte header is here. Then you have a lot of other kinds of header information, which some of which we will look soon. And then there are other kinds of header information, and then you have your image coming. Okay, so now we are going to consider the simplest version. Okay, so we are not going to worried about the compressed BMP format, etc. So let's go for the simplest format where it starts with BM. And so first, I'm going to read this entire thing, right? If I want to read this entire thing, what I will do is the following. I need to, I'll basically create a structure for this, right? I'll create a structure for this and then just read this information. Okay. Now, so let me just construct a structure for this. And so first is basically the header name, okay, which should contain BM. Then 4 bytes of file size, 2 bytes of unwanted things, and 4 bytes of some 4 bytes of basically the starting header. So I'm going to just do that right now. So I'm going to create a structure, struct. So what is this called? This is called as the BMP file, bitmap file header. So struct bitmap header. Okay. And so first 2 things is the right. So the header name. So let's say the name, and it's going to have 2 characters, 2 bytes, right? And the next is you need to have size of the BMP file. So that can be an unsigned int. So I'm going to use unsigned int. This is 4 bytes. I'm going to use unsigned int because in my machine an int is 4 bytes. Okay, that's why I'm using it. But if your machine it's different. If in your machine it's 2 bytes, you need to use a long int or something like that. Okay, so this is once again I'm using int because size of int is equal to 4 in my machine. Okay, and then I have basically 2 bytes of 2 bytes of unwanted things. So let me just have 4 bytes of so let's say garbage, right? And after that I have 4 bytes of the address. Okay, so 4 bytes of the starting address. Where does the image information start? So I'm going to again have unsigned int offset, image offset. Okay, right? Now this is clear. So the first thing, this should be equal to Bm, and unwanted, and this contains, so this is what we have. Now once I have this, let me just have, okay, I am going to now read this. To read from a binary file, you can't use fscanf. For this, you need to use something different, what is called as fread. So you want to read from the file, and I'm going to use fread. And the first thing you need to pass to the fread function is, you need to pass the address of the variable where you are going to retrieve, where you are going to store the information or the data which is retrieved from the file. So I just passed the header information. Next thing you need to pass is what is the size of this structure. So that's next. Next, after this, you need to pass how many such structures should you take, retrieve. That's one, and then you have FP. Okay. Once I have read that, what can we do now? Let's just print the first two characters and see. Okay. So this is header dot name 0, comma, right. Put some slash in. Okay, this should work. So let's compare and let's see. So I already have a file here. So this is already there. So therefore now I'm going to compile and run. So this is image.cc. It's compiled. There's something wrong. What is wrong? So this has to be as close. Next, it's compiled. So now just run. First two characters are BM. We have opened a BMP file. It's good, wonderful. So we have read the bitmap header. So there's a slight issue here which I never talked about. So one thing is that, so let me just print the size of this bitmap header. What is the size of this bitmap header? What is it, your guess? You can see that this int is, in my machine it's 4 bytes, garbage 4 bytes, size 4 bytes. So 4 plus 4 plus 4, 12 plus 2 characters. It is 14 bytes, right? So let's just run that and see. CCC image. Yeah, that's okay. It's saying 16 bytes. On the other hand, we were saying 14 bytes. So when I read this header, it actually read 16 bytes from the file. Okay, so why is this so? So this is because all the other, except for the name, the character, the name array, rest of the items are all of 4 bytes. All the rest of the members are all 4 bytes. On the other hand, the name is a 2 byte. So for efficiency of using the structure, C actually allocates 2 more bytes here. Okay, so that everything is like 4 bytes. So like 4, 4, 4, 4, it becomes 16 bytes. And then it can just, so C can make accessing this data, this structure more efficient. It just needs to go after, so from one member to go to the next member, it's 4 bytes. So it's going to be same so at every point. So that makes it easier to access members of the different members of the structure. And so C does this thing for efficiency purposes to make our program faster, etc. But this is now a headache for us because why? Because we wanted to take only the first 14 bytes of the structure of the file of the BMP file and store it here, but it now took 16 bytes. So we are taking unnecessarily the next 2 bytes, which should have gone somewhere else, and all these data values have now changed because of the same because of this reason. For example, we can just print the size and see what is the size of the file. Size or I'll just print up the offset also. So it's image offset. Yeah, so this is not, so size is just 90 bytes, see. So this is clearly not good. So I'm going to first read the only the name, okay, and it's of 2 characters, one unit, and then yeah, let's read. Next I'm going to read 3 integers starting from size. So it's going to be okay. So this should give me a correct. Right, now this is correct. So this is the offset is 54 and the size of this file is this 13. So this comes out to around some MBs. Okay, so this seems to be correct. So I'll just comment this bitmap also and let's just see. Right, so this is good. So we have offset, and so offset is basically the location from where the image information there in the file. The next thing, what is it being required? We don't know the height, the width of this file. We also need to check whether this file is doing some compression or something, because we are not interested in that. We are only interested in a file which does not have compression, right? So these things we need to clarify before we proceed further. So let's do that now. Okay, so that requires, we need to read another header file. The topmost header is this bitmap header, which is followed by a different header called a dib header. We need to basically write the structure for the dib header. So let's go and check it in the Wikipedia page. And here it is. Right. So the dib header comes up in various formats. That's the first thing. It depends on the different versions of this format. So initially it started with, it was made for Windows 2.0 BMP support, and then different formats are now being proposed. So in all DAB headers, the first 4 bytes are going to be the size of that header. Okay, so I'm going to have a structure which is going to store the DAB header. So first thing is the size of this header. So int, so let me have okay. Okay, so that's the first thing. Next thing is that the bitmap width in pixels. Okay. So the next 2 bytes is the bitmap width. The next 2 bytes to be the height. Okay, so let's try to capture those things. So After that, so color planes, number of pixels. Okay, so let's do let's do one thing. So this is a very old format. This is Windows 2.0 format, which is it's a 12-byte header. It's very old. So let's go to a little bit not that old. So let's just go here. So this is Windows bitmap info reader. So the size of the header is the first size. First is the header size, and then it's the width and height which are int. Earlier one was too short. Okay, and we have now width and height, followed by two things, which is first is color planes and the second is bits per pixel. So for that we can have some shortened. The next one is bits per pixel. Okay. Finally, the compression method and the image size. I stopped there because we are not interested in the rest of the structure. So what is compression method has to be 0 so this value has to be 0 to mean if there is no compression, that is going to be 0. Okay, and right. So we can read this now. Let's just try to read this and we can print each of this and see. So I'm going to read. Okay, so first I'll create a struct Bmp underscore header, Bmp header, and I'm going to write Bmp header here. Here we can have, so this is, we can just give the struct size, because here there's no issues with. So here I can give size because they are all integers or shortened, and like two shortens will form one int. So you can think of it as all ints, and therefore there is no reason for the C compiler to change the size of the structure to allocate for to optimize the code. So, okay, so that's not required here. So we can use struct here. Can use the size of the struct. Okay, I just read that, and now let's print each of the. So let's say header size %d followed by width followed by height followed by color planes followed by bits per pixel by compression followed by image. Right? Okay. Now we're going to make each of this. This is Bmp header dot header size. Now Bmp header dot width, Bmp header dot Bmp header dot right. So I'm trying to print all the elements of the structure, all the members of the structure. So that's the correct usage. I'm going to compile it. Okay, there's some error. So first of all, there is no semicolon somewhere in input. After struct, here. Next is DAB header dot size. No, that's not correct. So just you have to use the structure DAB header, right? So what is DAB dot? Okay, that's fix each one. Right, so that's done. Okay, that's good. Now I combine, I run, yeah. Okay, exactly like we want. What is this one comma here? This right. Okay, so first two characters BMP, so it's a BMP file and it looks at size this offset 54. Okay, header is 40 and height, width and height is 742 and 5. So the width is 585 and height is 742. So that's the picture I'm looking at, and pitch per pixel is 24 and compression is 0. So those are important things which we are interested in. We are only interested in an image of which is compression 0, where there is no compression, and whose bits per pixel is 24. So that's the kind of function we are interested in. So let me just do the following. Let's check all the conditions we are interested in. So first of all, the header has to be so BM, right? Otherwise, we are not going to. Otherwise, we are going to. I'm going to close this file and just leave. Okay. So this we can have. Okay, so we're going to leave if the first two letters are not BM. Next thing we need to see is whether the compression is 0. Okay, few things. The header size is 40 because that's the header size we are looking at. You're not interested in other header size. Then the compression is 0. And the pitch per pixel is 24. Okay. All those three has to be okay. If all of them are correct, we can go. So if we can continue. If any of them is wrong, so that's a mistake we made. So if the header is not this, right? If it's not equal to, okay, so when you have to make it into not, it has to be or, because even if one of them is not equal to, the first one is not equal to B and second one is not equal to M, I need to return, right? So this is exactly what we have to do here also. So if it's not equal, even one of them is not equal to, I want to return. And let's say I return with value 1 to mean that this did not happen. We were not able to. We are not able to open the. There's some error. Either we are not able to open the file, just like here, or it's not a BMP file, or it's not a BMP file which we the kind of BMP file we were interested in. Okay. We need to now read the image. Now to read the image, we need to first go to the location of the image. Where does the image start? So the image information starts from, so we have that in the bitmap header, image offset. So from the image offset position, from that location only, the image information starts. So we are not interested in anything in the file between and until that location, right? So what we can do is the following. I'm going to use the function fseek, which will take you there. So first I pass the pointer, and then how many steps, how many bytes from the beginning are we interested in? Should we go? So it's seek. So seek is basically move the file pointer to that position. Okay. So which position are we interested in? The position we are interested in is Bmp header. No, header dot header dot image offset, right? Image offset, and from where, starting from which location? So that's where we said seek underscore set to mean that starting from the beginning, we need to we have to go image underscore offset many positions. So that comes out to be clearly just after this header, because this header is 40 bytes and the previous header was 14 bytes. So obviously if you had read all the 40 bytes of this header, we could have just gone into the image information. But maybe in a different file, you have written some unwanted things in between this header and the image, start of the image, right? Okay, so now we have moved our cursor, or we have moved our file pointer to this position in the image, in this file. Next question is, how is this image represented? Okay, so how is an image represented in the file? Now, every pixel, every point in an image consists of 3 values called as how much red component is there in that value, how much green component, and how much blue component. So these are called as RGB values. Okay. Now I'll show you an example. So here you can see this color square, right? So this is now set to red, maximum red. So maximum red value is now 255. Okay. So it's now set to maximum red, so it's 255. If I make everything 0, red value to be 0, green to be 0, and blue to be 0, the square becomes black. So 0, 0, 0 is black. On the other hand, if it's 255, 255, 255 is white. As you can see, if it's 0 red and 255 green and 255 blue, it's some mixture of green and blue. Okay, so this is fully blue. So because it's only the blue component. Now this has only the green components, green. Okay, so any color can be represented using this RGB values, where R, G, and B takes values from 0 to 255. Okay, so I'm going to create a data structure. So every pixel in an image consists of these 3 information, so red, green, and blue. So that's why we also saw that bits per pixel. So every pixel information is stored in 24 bits. So why is it 24 bits? Because each red takes 8 bits, 1 byte. So 0 to 55 can be stored in 1 byte. Green takes 1 byte, blue takes 1 byte. So that is 8 into 3. 24 bits is required to store this information for a pixel. So that's exactly what we had wanted, and this is the kind of image we are going to open, right? Okay, so I know this image consists of RGB values. So now let me go to the wiki page for Bmp file format, and it says that okay, so as you can see, so the 3 bytes are stored in the form blue, green, and red. It's not in RGB, but it's RGB reverse. So first will be blue, second green, and third red. So let's just have that. Okay. So let's just create a structure along those lines. Struct RGB. And so this is, since it can take each of the red, green and blue can take 0 to 55, all positive numbers, so I am going to use an unsigned character. So this is the other way, right? So first we want blue, then red, and then blue, red, green. No, sorry, blue, green, red. That's what. RGB in the reverse. Okay. Now every pixel has that information. So now to take this, the entire information, so I'm going to take this entire information into an array. And for that purpose, what we will do is the following. Okay. So how many, what should be my, so the array is going to be a two-dimensional array, which I'm going to dynamically allocate. And I know the height and width. So let me write a function to do that. So void. So let me say read image, and it's going to get the file pointer fp. Okay. So file pointer fp is passed, and then first question is that I have to allocate to construct a. Okay, so let's say I'm going to construct a structure called as image. Okay, it's going to contain the following. It's going to contain it's going to contain a pointer to an RGB structure. Why? Because I want a two-dimensional structure, and we saw that a two-dimensional structure, if I want to allocate the entire two-dimensional structure dynamically, I need a pointer to a pointer. And so I have that, and then I'm also going to have the information on height and width. Height and width. Okay. Right. It's clear? It's clear. Okay, so let's just now do that. So okay, so I also have to pass to this function the height and width of the. So first thing I'm going to do is that I'm going to allocate memory for this image. And what I'm going to do is the following. So we can just return this image. Okay, and this is going to have first thing I allocate is I allocate the height, right? How many? So what is height? How much height do I want? I want its height into, so one-dimensional array basically the height. So I want height into size of a pointer. Okay. Because I want to store that many pointers. Right. Next is I'm going to go through the height in. I'm going to go through the height, and at every location I'm going to allocate memory for each of this. This is okay. We need to allocate memory for each of the row of the image. And how much should we do that? We should, so that's basically the width, right? And width into struct RGB. because every pixel has an RGB values, a 24 bits, and so the memory we need to allocate is this much width into that much. So I'm going to return the bit, and one small catch here though, that is okay. So let's just do the following also. I'm going to set height is equal to height of the member of the structure, because we will later use this member. Just one catch though. So the main point is that the picture is not represented top down as you see. It's actually represented bottom up. First, the bottommost row is in the file, then the second most, then the third most, etc. So it's since it's bottommost, and I would like my array to be top down, I'm going to put in the other way. Okay, so this is done. We have though not done one thing. What is that? That is, we have allocated memory for the, so we have used malloc and we haven't freed it. So we need to have a function to free it. Free image, right? This should be such function should be written as soon as we allocate memory. We should write a function to free it, and then we know we will use it later. So let me just copy this. So I didn't create this inti, right? No. Now let me just copy this here. And I'm going to write 3. So that's done. Next thing is free. So both the arrays are now free. So this has to be called here. This has to be called actually just before we say, just after we close the file, before we return. Okay. I didn't read the file, right? So I just allocated memory, and what should I do here? I should read the file. And to read the file, I'm going to fread, and I'm going to pass this. This is my address followed by the next is the size. How many do I want? I want with many. And what is the size of each? Size of each is command. Right. So this is now going to go. We have now read all the image information into the image structure. Good. And we have now freed the image. Okay, so that function is also there. Everything is fine. So this is now RGB is in it's a 3-color format, red, green, blue format. Each pixel has now red, green, blue information, and I'm going to make this into a black and white image first. Our aim is to now write this into a new file, which is and make a black and white picture out of this. So first of all, what is the picture we are looking at? So the picture we are looking at is the following picture. Okay, so and then we are going to make it into a black and white picture. So, right. First thing to do is how to convert an RGB value into a black and white value. So that's the first function I'm going to write. I'm going to write. Actually, I'm saying cat. So we are going to give. So given this RGB values, we're going to give an intensity value. We're going to return an intensity value called as the grayscale value, which is going to be a black and white value, like fully dark to a fully white value, but it's in the black and white range. So it's called as a grayscale value, and given an RGB value, I'm going to convert it into a grayscale value, and just call it grayscale. Okay, and I'm going to get an RGB, right? And the thing is, it's going to be fairly easy. It's going to say first, let's just have going to be RGB dot red. So it's red, green, blue, right? Plus RGB dot red, green plus RGB dot blue, and then divide by 3. That's one way to do it. But other way is that there's going to be a weight attached with all of it. And the weight is something like this, 0.3 into red, 0.6 into green, and the remaining is 0.1. This is the weight. And this is going to give us a better grayscale value. And this value I'm going to store it into, so let's write a function, convert image into a grayscale value. Image to grayscale, RGB image to grayscale. I'm going to get an image. So what do? I have say 0 by less than dot height. Dot width. So that gives me dot RGB of I of j gives me the structure, and that structure I'm going to make everything equal to the grayscale value. Okay, red, green, blue, all equal to grayscale of bit of RGB of I. So now this is now converted into grayscale. Once this is done, finally we'll write this image into a new file. Right, so void create PW. So what are the things to be passed? So both the header files are required. So struct. Okay, let me just copy them. This header is required because I'm going to write a new Bmp file. So that means I need to have all the header information. Since I'm going to use the same file. Same image, right? We have just changed the color values. So therefore, I can use the same header information without any issues. And finally, also the image. So, right, and we're going to use this. First thing is we're going to write. So we use fwrite, and for fwrite, I'm going to pass the same thing I'm going to do here. Sorry, we have to first create a file. Okay, file fpw is equal to fopen, and it's a new bmp, and now write. So write, we can write if fpw is equal to null, I'm going to return the point of the null. Otherwise, I'm going to write, and I'm going to write to fpw. So we have written. Okay, I have written both the header and size. Now, next thing is we have to have the DAB header. We have to write the DAB header. So in this case, okay, so let me first write the DAB header, comma, structure. Okay, so the DAB header is actually 40 bytes, but we have used only structure. We have taken only 24 bytes or something. So I have to add the extra. We have to add the extra bytes in the structure. Let's do that. Okay, that's also done. Now we have to write the image. So for that, I'm going to copy this. I'm going to copy this. And finally, we need to close this. Right. We didn't call this RGB to grayscale. Let's just do that now. We just did that. I called RGB, so we just pass that image there, and the image will now be modified. We made into grayscale, and then we just write this information in the file. This should work. So we should have a new BMP in the folder which is black and white. Let's just do that. Okay, some error. No matching of the free image. So free image should have should have the image. Next is there's no width. Where is it? We are in 79. There's no width, so it is width of width. Right. Yeah, so there's no comma here. Right, I is not there. Right. So there is some equal to somewhere. Where is this? Line number 79. This should be greater than or equal to. Did I make a mistake somewhere else also? Yeah, so here also. So this is a dangerous mistake, right? It has to be greater than or equal to. Go from height -1 to 0 and back. What is it? I think somewhere I is not 79. 79 seems to be. Oh, what is height? Again, where is height in 51? 83. We need to have a look at. This should work. Let's see. Hope. Okay, so this is the file information. Now in the folder there should be a black and white image. Let's see. No, there's no black and white image. Why? Maybe I didn't call that function. Okay, good. I never called this function, so let's just call it. Let's call this function. We need to first pass the header. Next, we need to pass the DAB header. Next, I need to pass the image. That's it. Right. really good. There is this black and white. It's not good, right? So our calculation for black and white was not good. So we can change it. We can change it and see. We made a small mistake here in the grayscale function. The mistake is that, so the grayscale is supposed to be ranging from 0 to 255. On the other hand, what we have just now written is going to, the max value of this is only going to be 255 by 3. That's because we have taken the ratios correctly. We have said that, okay, red contributes 30%, the green 60%, and the blue 10%, right? But then I divide by 3, and that's why the image is darker. So let's just brighten it up by not dividing by 3 should work. gcc image.cc slash a.out. Let's look at the picture. Yeah, so now the picture seems to be much better. Okay, so we have converted to the grayscale value and things are working fine. Now there's one more important error we made, and that is in this function on read image. And because here right now I have used width, so as you could see, this function reads the width. So the DAB header as the width, which is read from the file, right? And that's assumed to be the width. That's all correct. So the width of the image is it's read and it's now passed to this function as width, and it's stored in the picture width. So this is correct. But there's a but, and so let me try to explain. There is one issue here. Let me try to explain. So here in this picture, I'm trying to say that, okay, the width of the image is 5 pixels. Okay, as an example, there's just one row of 5 pixels. So how many bytes does these 5 pixels take? So this is first pixel will take 3 bytes, second pixel 3 bytes, third pixel 3 bytes. So why is it 3? Because the red, green, and blue each takes a byte. Just the fourth one takes a 3 byte, and the fifth one takes 3 bytes. But in the so this comes out to be in total how many bytes? In total, this comes out to be 5 into 3, 15 bytes, right? So in a BMP file, they are going to add extra 1 byte here to make this 16 bytes. Okay, so what they do is they will, let's just take this out. I'm going to add this extra 1 byte here. So this will now become 16 bytes in total. Okay, so why 16? Because it's a multiple of 4. So how much ever the bytes are, so if your row contains x bytes, they're going to take a value, the nearest value, I mean larger than x, which is divisible by 4. Okay, so that will be the row. So what will be this extra byte? So that will be some random arbitrary bytes, probably mostly 0, which are not to be used. So it's just kept in the file to make it aligned with it's aligned with 4 bytes. Okay, so each row actually consists of now 16 bytes here, and in our case our width was 585, and therefore it is 585 into 3 many bytes, which is not obviously divisible by 4, right? So it has to, some extra bytes are required which are padded. Now this will create, so if we don't take care of that, what will happen is that we are actually not reading it properly. So what in the present scenario, what we are reading is the following. So we read, so the first row reads this much information. Okay, the first 15 bytes are read because our structure is like 15 bytes, and it will read the 15 bytes. Okay, 3 into 5 many, the width is 5, so 3 into 5 many bytes are stored. Okay, so that will go into the first row. Now the second row starts reading from this point. Okay, so the second row, this point is now copied into the next, so the as the R value for the first pixel of the next row. all the information is stored like this now, but somehow we are not seeing that the issue here. Because why? Because we are writing a new BMP file and seeing it, right? So when I write the new BMP file, the new BMP file is also going to write 15 bytes followed by a new image starting from the next row starts from here. Okay, so when the BMP reader reads that, they are going to read it perfectly fine. So that's one reason why we are not seeing it here. But if we try to manipulate it, the image, it's going to create some. We won't be exactly dealing with the ijth pixel. We won't be exactly manipulating the ijth pixel. Okay. So once more, as we said, the 16th byte, right, will be read as the first byte for the next row. So the next row actually starts from here, right? So this has to be read only after you read this extra 1 byte also, but that's not done here. So we have to do that. So we have to add that extra byte while reading. And how am I going to do that? So I'm going to add a new variable. Let's say bytes to read. Okay, I'm going to find that out. So that let me write the shortcut for it. That's going to be this. So that's given in this Wikipedia page. It's bits per pixel, that's 24, and image width, that's width plus 31 by 32, and I add the entire thing with 4, with multiply with 4. So that's actually the bytes to store, the bytes we require. So the bytes we need to read. Is that clear? So that's how it should be. And right, so I'll just change here. So this is, these many bytes have to be read, and so let's just have it comma. So these many bytes have to be read. Now, so how many structures should we allocate? So the structures we have to allocate is the following: structs so number of RGB, and the number of RGBs should be, how many RGB structures should we require? So we require bytes to read by size of struct RGB, but this will be if the bytes is 16 and the size of RGB is like 3 bytes, right? So 16 by 3 will be 5, but we require plus 1 because we need just one more structure to store this extra byte information. So I'll take that and I'm going to change this bit to number of RGB bytes, number of RGBs required. So this, now I just add declare these two extra variables, and now I have a situation where I read the bytes taking care of this extra padding, and I also allocate memory enough to take care of this extra padding. But remember that I had to take care of it is in the RGB structure, right? So that's why we did it like this. So we have this extra 1 RGB. The last RGB structure is kind of lying there vacant with no use in some sense. Okay, right. So we have that now. So this is how I read, and I can go back and I can write it like this. How do I write? I have to write these many bytes. So let's just have that. I'm going to write this many bytes. And okay, now let's compile and see. GCC image. Okay, there's somewhere something. So this has compiled well, and let's look at the image. Okay, so the image is now perfect. The last thing we are going to do is the following. We are going to display this image in text format. That's really interesting, right? It's called as text art. You can search Google this and see if you are interested. So it's called as text art. What does text art do? It's so in text mode, how can I print, show an image? So this has been long back before the arrival of color printers and etc. Or earlier the printing was mostly text-based printers. So at that time, if you wanted to print someone's face, for example, it was kind of difficult because it's not a pixel-like printer. It was mostly a text-based printers. So at that case, in that scenario, how can you print some picture? So that's how this text art got developed, and it's now a cool thing. So so the same image. Let's try to do a text art and see how it looks like. It's going to come pretty well. Let me call this function image to text, and I'm going to take an image, right? And I'm going to go from through each pixel of the image. So this has to be image.height. What do I do? We're going to, so first thing I'm going to do is I'm going to copy this below my grayscale value. There is the grayscale. So let's have it there. So I'm going to take a picture and I'm going to call the grayscale value. So grayscale is equal to grayscale of pix dot so it's img, right? So img dot rgb of I of j. So I'm going to get this grayscale value, and once I have that, next thing I need to do is, so I'm going to declare the variables I and j. So I'm going to partition the so the grayscale ranges from 0 to 255. I'm going to partition this grayscale into, let's say, 8 parts. And what I do is the following. And I'm going to, so it's going to be partitioned into 8 parts. So what is 256 by 8? 256 by 8 comes out to be around, so it's 32. 0 to 31 is going to go into the first basket. So I'm going to partition the 0 to 255 into 8 parts, and 0 to 31 goes into the first basket, 32 to 63 goes into the second basket, etc. etc. Okay, so 0 to 31, 0 to 31, 32 to 63, then 64 to 95, 96 to 127. Okay, so that's 4, and then that's 4 parts, and then 4 more parts will take me to 255. Okay, so this I'm going to partition it into these many parts, and each of these parts I'm going to assign one character. That's my text character for. So text pixel is going to be that character. So it's an array of 8 parts, and the darkest letter is going to be at, for example, because it's going to be colored. It's mostly covered, so it's the darkest, and the next can be something like a hash, which is a little less dark. Then next you can have something like a dollar, or let's go for something lighter and maybe a percentage. You can have a next one to be O. Then you can have a little more lighter things like an A, followed by or a dash, followed by a dot, followed by a total blank. So that gives me 8 characters. As you could see, so my aim is at is the darkest, hash is the second darkest, and percentage is third, etc., etc., and blank is basically pure white. What I do is the following. So basically, I'm partitioning the, the the grayscale values into. I'm going to assign each grayscale value one of this text letters. And how am I going to do that? So I'll just print that character, which is going to be text pixel by, so gs is the grayscale value. I'm going to divide by 32, which will give me the value we are looking for. Okay, so which is going to give me the the text symbols associated with that grayscale value, right? And after this, I'm going to print a new line to, so that the next line it comes to the next line. This should work. I can just call this function and see how the text, so the same image is printed in a text format. I'm going to call this function before the create binary image is shown. We have to do one small change here, and that small change is this following. Uh, so my terminal is actually, it's a dark terminal. It's not white terminal. So since it's a dark terminal, I have to invert this. This is going to be inverted. So it's going to be 8 minus this value, right? Or rather 7 minus whatever this value. So this is going to, so this way I get, I mean, I had said that at is supposed to be the darkest, but when I print, at will become the whitest because my text is now in white and background is going to be the black. So I just inverted the 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 whiteness or the blackness in the picture. So the grayscale, and now I'm going to run this. Before I do that, I want this entire image to be on screen. So for that reason, I'm going to reduce the size of this. So let me first compile this. And now I'm going to reduce the size of the text for the simple reason that I want the entire picture to be on screen. And okay, so I just did this. Right. Now let's just run it and see how it's going to be. There. Here is your Tendulkar. So this is the grayscale Tendulkar. Right. So this is text art for you. And you can create other images if you're interested, and you can just take an image and take a Bmp image, use this program to print text art, create interesting images. Okay, so this looks good, and as you could see, we can understand all the. I mean, we can see all the details of the image through this. So this is good. We will finally do one more thing. Let's take this. So right now the image name is hard coded. I don't like that. I would prefer if the image name can be passed as a parameter through the command line. So let's have that now. So I'm taking the file name here. And I'm going to pass this file name through the main program function. So if argc is less than 2, so that means is equal to 1. So let's have it just is not equal to 2 because we want just 2 parameters. One is the dot slash arrow out, and the second is the file name which we need to open, which we are interested in opening. And if arg is not equal to 2, I'm going to print please use command so dot slash arrow out followed by file to open.bmp. So we need to use this command, right? And then basically return. On the other hand, if it is 2, then it's easy. I just have to call this argv function with the first parameter. What's the first parameter? 0th one will be dot slash arrow out, and first will be the file we want to open. So let's try to run that, and let's first compile. Just compile, and before I run, so I will write something like dot slash arrow out, and so, okay, we'll see what this file is. So it's a Bmp file. I'm going to now reduce its size. So let's run it. Right. So we got a nice picture of Tom and Jerry here. It's good. So this is all in text mode. I mean, looks really nice, even in text mode, right? We don't require the graphics to show images. It really looks nice. Next one. Here we have Sachin. To summarize, what did we see? We saw how to open a BMP image and how to write a BMP image. We also understood how the header file concept is in a BMP image. We also understood how an image is stored as RGB values. And the images are uncompressed format. And so these are things which we saw, and then we also saw how to display images in text format, right? Apart from this, in C programming, as a C programming session, we learned how to use structures, how to use malloc, how to take parameters from the terminal. Yeah, so so basically we saw all kinds of manipulations of structures and allocating memory, read, fread and fwrite. So how reading and writing from binary images. These are things we saw. This is a nice lab session which covers a lot of things, and this brings everything we understood till now into one single big application, and which is an interesting application in itself. Plus, we also got to know how to use all the ideas in C we learned. I will leave you with some pictures generated by our TechStart program. Finally, a big thank you for sitting through this long session. Thanks. Bye.